Thanks, Michael. Thanks a lot for having me here and giving me an opportunity to speak to the audience here. Thank you. Okay, good. So thank you, guys. I'm Karan, and I work for Red Hat as a principal architect and developer evangelist for Red Hat Developers Business Unit. And you can follow me on LinkedIn, and I typically write a lot around cloud native and Kubernetes and distributed systems, how to do a solution designing for those kind of environments. So you can check out my blogs for new entries. So that's what I do. And today we're going to talk about GitHub and GitHub Actions and Kubernetes. I can see there have been a lot of talks previous to me who are going extremely deep on Python. So you will not expect this like a lot of Python in this, but yeah, you will touch upon the standard software development practices around GitOps and this. So we're gonna go over GitOps. We're gonna get over Kubernetes and Agile development, CI/CD, and touch upon GitOps and ArgoCD stuff, and then GitHub Actions, which is how you can simplify your development cycles using GitHub Actions, which is a fantastic tool. And then we're gonna go over a few demos that will give you an idea how you could use GitHub Actions in your day-to-day software development practice. So let's begin. So you guys know this already, but for the sake of people who will watch this later on YouTube or somewhere else, Git is just a tool for version control. One of the most popular tool on version control, and GitHub is a SaaS provider or exclusively on cloud, which gives a nice interface and a lot of other features on top of Git. So that's the basic, and we're gonna do a lot of stuff around Kubernetes today. So let's understand what is Kubernetes in one line. Kubernetes is just an open source orchestration software for managing and scaling a lot of containers at scale, and open source by Google, and lots of people use it, and pretty strong community that basically backs Kubernetes project. And OpenShift is an enterprise distribution or enterprise-ready distribution for Kubernetes, which helps you provide a seamless environment that could run Kubernetes across multiple clouds. So maybe Azure, Google, and Microsoft, and at the same time your on-premise environment. So you need some kind of environment which is cloud agnostic. So OpenShift is the open source enterprise-ready distribution from Red Hat. And OpenShift is Kubernetes, so it just packs the bits from there. Touching upon the Agile and DevOps. So what is Agile and what is DevOps and what is CI/CD? We go over these terms a lot, and I just thought, okay, let's go two steps back and have a quick discussion on this. So Agile is a framework. It helps you to build a great softwares and across multiple teams. So it's a framework. It's a state of mind. And DevOps basically is a part of Agile. It helps you use Agile principles for Agile for building the right software in the most comprehensive way. So this is how DevOps can help big teams and small teams as well. And touching upon CI/CD is a tactic. It's a way to implement DevOps. Continuous integration, continuous delivery makes your team agile, which means your team can produce a lot of good fixes, new releases efficiently and periodically. So basis upon a lot of automation that goes into CI/CD. So this is how these three terms revolve around, and this is how they look like they are basically interdependent on each other. And how does the CI/CD pipeline look like? So as a developer, you will write your code, you will move this into Git, your version control system, and then depending on the dependencies, your system, your CI continuous integration will build your code and then do some unit test, and then later on it will try to deploy it on an environment that could be any environment, right? There's nothing specific here. So from the deployment part, continuous deployment, which is the term used to explain all the coming stages. comes up, and then your code got deployed, and then if you have some automation in place, it will test your code, and then your code will move to production, and then there is a continuous production feedback loop that will again go back to the developers, and then you release new fixes. And this is how a continuous integration and continuous deployment pipeline looks like. So now let's throw some more words to this mix. We hear about GitOps and then ArgoCD and how these new upcoming patterns and technologies gonna change our software development. So we have in the 2 slides back, we talked about Agile and DevOps, and then we talked about CI/CD, and so it's a tactic. So CI and CD are 2 different parts. So what GitOps does is GitOps consumes the CI part of DevOps. So if you can see this, GitOps basically overlaps to some extent onto GitOps world, where it adopts the continuous integration benefits of DevOps, while the CD, the continuous deployment part, is something that GitOps manages by itself. So GitOps, one of the most popular tool out there is ArgoCD, which runs on Kubernetes. It's a controller which will continuously monitor your Git repository, not specifically GitHub, but yeah, any Git repository. And if there is any new change or any change in your GitHub or Git repository, ArgoCD will basically take those changes and deploy your application onto the cluster. So the continuous deployment part is something that GitOps practice has of its own, while it borrow the continuous integration from DevOps universe. And how the workflow looks like for when we have, let's say, GitHub Actions and others. So I'm going to talk about GitHub Actions in the upcoming slides. So yeah, GitHub Action is very specific to GitHub. You'll not find this on any other Git related SaaS provider like GitLab or others. But yeah, specific to GitHub. GitHub is one of the most popular environment for the developers. So yes, typically you have your repository, and then like I explained before, for GitOps, you will have ArgoCD will keep monitoring your Git repositories and deploy that onto Kubernetes, specifically in Kubernetes, right? ArgoCD is used in realm of Kubernetes, not outside of that, as of now. On the other hand, GitHub Actions basically triggers any trigger that you do on GitHub that invokes a GitHub action, and using GitHub action, you can deploy this on Kubernetes. So we're going to talk about GitHub Actions and how to deploy that on Kubernetes in today's talk. So yes, that's what I told about. You will, as a new action comes up, GitHub action will take necessary steps and deploy your code onto the Kubernetes cluster. So what are different actions that we're going to see today? So as a developer, you will write some code, you will write some fixes on your local repository, and then the first thing that you will do is you'll do git push. So git push is a GitHub action, and then once push is done, you will create a pull request, a PR, to the project that you're working on. Once the PR is there, PR is again another action for Git. And then you want, like, hey, as soon as I do a git push and create a new PR, maybe my code should get deployed onto development environment so that my team can take a look. Right, and once the original or once the maintainer of the project checks your PR and then is ready to merge, he will merge the pull request, and again there will be another trigger that will deploy your code automatically onto staging environment. And then once the code is ready, and once you decide that, okay, we need to do create a new tag, maybe version it and do a release of the software that you're working on, you will do those actions on the GitHub UI, and then that will trigger another action, which means it will deploy your code automatically onto production and onto Kubernetes in my case. All right, so this is how typically an app to GitHub Actions to Kubernetes workflow look like. There are a lot of actions which, there are a lot of event types that GitHub supports right now. So you can take a look on their website. But yeah, creating some forks and writing some issues or doing some creating a pull request, and lots of events types are available, which gives you power to automate your own workflow cycles. Coming to GitHub Actions, so GitHub Action is kind of a ring in a ring kind of a concept. So at the base we have actions, which are the actual tasks that needs to be performed. Those are wrapped into steps, and these steps are wrapped into jobs. So in a job can have multiple steps, and steps can have multiple actions underneath. And all these jobs could be together called as workflows, and workflows run or get deployed, or basically workflow get executed on a runner. It could be a shared runner from GitHub, or it could be your own runner, dedicated runner on any compute instance. So this is how the core concept of GitHub Actions look like. And the way I think is GitHub Actions is like IFTTT for GitHub repository. So like if then do that kind of architecture that you can build using GitHub Actions. So here is one sample GitHub Actions workflow file that I created for you guys. So on top you can see there are triggers like what you will describe to your workflow, like when you want your pipeline to get triggered. So it's a trigger, and underneath you can see there is a facility to use your own environment variables or your own secrets. So these secrets could be defined into GitHub. GitHub SaaS portal, like username and password and endpoints and tokens. All of those are secrets that you could define, and then later on use those secrets in your workflows. And then comes the job, and under job there's a workflow, and under workflow comprises of a lot of steps. So here in my case, I'm checking out a branch, which is my branch, where I'm working on, and then you will run some shell commands. These are some typical commands that you will typically do on your local machine. Hey, build Docker image and log into Docker and push the image to Docker Hub, and then change some maybe update the Docker image file into my deployment files, like that. And once you do those changes, you want to do more things like deploying my code onto the actual infrastructure. So for that, first of all, we need to authenticate against the infrastructure that we're using. So in this case, we are using GitHub Actions by Red Hat, which allows you to first log into the OpenShift cluster or Kubernetes cluster. There are a lot of actions available out there. Log into the cluster, and then once you're logged in, deploy the app onto the OpenShift cluster using a deployment file, which is a YAML file in this case. So this is how a step-by-step workflow, a GitHub Actions workflow look like. In the demo setup that I'm going to show you right in next two slides, a typical development setup, you will be working locally. You'll do a git push to the repository onto GitHub, and then there would be and you'll create a pull request from dev branch to main branch, and then it would invoke a GitHub action, and it will deploy your code onto OpenShift cluster. And then, a senior developer will basically merge your PR, and then they will create a tag, and they will release a new version of the software, which in turns invoke more GitHub actions and deploy your code onto multiple or same or maybe different Kubernetes or OpenShift clusters. So this is how we're gonna see. So let's deep down into the demo. So let me see where I am. Okay, so first of all, I'm gonna go and to developers.redhat.com to get access to my OpenShift cluster. So I'll go to Developer Sandbox, which is kind of a free OpenShift cluster for all the developers out there. You can simply order one free of cost and deploy that. So I'm gonna start using your sandbox. And by the way, this keeps running for you. So if you deploy an app, that will stay there. So I'm gonna log into my environment here, my OpenShift environment. Okay, let me get rid of this again. Okay. Skip the tour. I don't want any tour right now. Okay, so I have like, a few things running on my cluster. Great. I'll switch back to my repository. Let's say I'm gonna use one. So I'm gonna show you 2 demos today. So for now, let's see one more interactive one. So yes, I have, for example, this basic code base, which is kind of a racing game. So, okay, I want to do some change. I'm a developer. I'm into my shell. I'm on local machine. I want to do some changes to my code base. Let's do some very simple change, because I want to do a git commit and git push. I'll change my README file, the simplest one that I can get right now. And then what I'll do as a developer is I'll kind of, do a git push. Okay, hold on. Why this is hanging? Okay, so I'll add my file and do some push into the dev branch. Okay, so my code is now pushed to the dev branch on GitHub. I'll go to GitHub and check where's my code. This is not the one. Okay, I'll go here and I'll see there's already a PR opened already. That's the reason the code will go directly to this PR. And as soon as I push it, there is a GitHub action which will get triggered. I'm going to show you how does it look like, but this is how, once a GitHub action runs, it's doing all the steps which I instructed GitHub action to take care, like build my Docker image and log it Docker and push my image to the registry. And then, it will update my deployment files. Typically, all the things that you'll typically do on your local machine, I just automate all of these things. And then it will basically deploy my code onto my OpenShift cluster. So logging to OpenShift, and it is doing a deployment, and then it will do a commit, or not commit. It will kind of add a comment in my. Yes, so this is done. So it should give you a green check. Okay, good. So this is deployed successfully, and it will add a new comment. I mean, again, I automated this thing. So it will add a new comment to my, like 24 seconds ago, the Git bot comment, the GitHub bot commented, hey, your code has been deployed and it is ready for testing. Here's the endpoint. So we're gonna see this. So this might take a few minutes to, okay, so now my app is ready on OpenShift without touching anything, and I basically can play my game, which I'll do it after this call, or I've been playing this since last week. So this is how, just to show you how does it look like. Okay, I need to close this for now. Yeah, okay, so I mean, you got an idea, right? So I'll close this for now. So this is how the pipeline looks like. Let me go back. And so since we have not seen anything, I was just going very superficial on this one, just to show you how the pipeline looks like. Let's go into slightly more depth right here. And I'm going to go show you for a new project, how the file looks like. So in this, what I'm doing is, so first of all, you will create a .github directory inside your repository and add another directory called as workflow. This is important. You don't need to mess around with these two kind of naming conventions here, because this is how they know this is a GitHub action and they need to do something else on your repository. So after that, you can create as many workflows as you like. So I have 4 workflows in my architecture here. So first one is, okay, deploy the code coming from the PR before the PR merge. So as soon as a developer kind of creates a new pull request on the repository on the main branch, my code should get deployed. So that's a trigger. I have all these secrets defined, like username and password and my OpenShift environment variables. And then I'm doing a checkout. And then, I'm building, I'm just getting the SHA of my commit, so that, I can just append that to my Docker image, so that I can have, a lot of Docker files. And if I want to go back in time, I can use those SHAs. I log in to Docker. GitHub action will again push it to Docker, and then it will basically update my OpenShift deployment file, which looks like this. If you're wondering how does it look like, so you will define a secret first, and then you will deploy a service, and then you will deploy you will deploy a deployment, create a deployment type of OpenShift and Kubernetes. And basically, I'm just updating this section using a sed command, like where what would be the image name, this container has to come up, and then I'm exposing this outside for the external world. So nothing fancy here. I'm just using sed, and sed basically, update my registry environments, registry details, and then it will update my image name. It will log in to the OpenShift cluster. It will deploy my app to the OpenShift cluster, and then it will basically get the route name and add a new comment into the pull request, which makes life easy for in the development cycle, which I believe, right? So this is how the first workflow look like. And then next, once the senior developer verified your code and they are ready to merge, they will basically merge your changes into the main branch. Again, exactly the same thing will happen. You could change an environment, like, hey, you can instruct GitHub or GitHub Action to deploy on your own environment. Like, hey, deploy this to dev or to prod or to staging, whatever you want to call it. You'll just change your server URLs or open Kubernetes server API server URL from here that you can manage, right? So this would be the trigger. Again, most of the file is same. The third one would be, okay, now I want to create a new tag and I want to deploy this into pre-production, right? Since I don't have another cluster running at the moment, but you can just change the environment variable, add a new URL, or make sure that you can point this action to deployed on a different URL. Just change these two parameters in here, and your code would be ready to go to pre-prod environment. And later on, exactly the same file. As soon as my release is created, I'll create a new release and create it. It will deploy my code, right? So let's go and deploy one of the app, the most simplest app that you guys can think of right now. Again, coming back from all the organizers here, all the people who presented before me, this 6-line code, thanks to Python. It's not Java, otherwise it would have been like 15 lines just for hello world. Okay, so what should we do? Should we, let's change it, right? We are a developer, let's change it. Okay, hello world from extreme Python conf, okay? I changed it. I saved my file. I'll go to the right shell. I'm in the right shell, yes. Clear and git status. I see my changes. Yes, I have one file change. I'll do a commit. Oh, not this one. I'll do a commit. It's not fixes in docs. It's fixes in main.py. And I want to push this to my development branch. Okay, I'll do a push. So at this time, there would be no action that got triggers. I'll go back to my repository. This is my branch. There is no, I think there's no PR at the moment. I'll go to my code base as a developer, or let's say as a junior developer. I'll go to my right branch and okay, one commit, and then okay, I want to create a PR. So I'll create a PR here, like hey, hello world works fine. Okay, it's just one commit. I'll do a PR. So as soon as I do a PR, I instructed GitHub Actions to take an action to deploy this to a development environment. So that's what GitHub is doing right now. So it is doing it. I can see this. Again, it will follow the same structure. Building container. Meanwhile, yeah, this is not very fancy. Maybe for the people who are new to this, maybe this is a Docker file looks like. It is nothing fancy here. I'm just using a UBI 7-line Docker file, which will install my dependencies and then run my expose using UVCon my server on port 8080. Nothing very fancy again. Okay, so this is going pretty good right now. So it is authenticating right now using the credentials and deploying it to OpenShift, deployed, and adding a comment to my existing PR. Okay, it's deployed. But if you see closely, the PR has not been merged yet. The PR is still open, but it says that, hey, your code is up and running at this URL. I'll open this. Let's see what it's got for me. If the cluster survey is up, okay, yes, my application, my Python app is serving, my fast API is serving the request, which is hello Python conf. All right, cool. So the code looks good to me. I'll do a merge. Okay, merge this from my development to my master branch. I do a merge, and again, this should trigger. Trigger. Yes, it will kind of launch. Okay, yeah. I need to go to actions to see where it is doing where it is running the action. So deploying the code. As soon as I hit the PR, it's now deploying the code to maybe another test cluster or a QA cluster, whatever you like to call it. So that's not very fancy. I'm going to show you one more thing here, which is pretty important. So to define the environment variables, you need to head over to settings of the repository and go to secrets. Here you will define all your secrets, which your action gonna use. So Docker username and Docker password, and this is all stored on GitHub. Keep in mind that you could not view your credentials. Once you create that, the only option that you can do is, or only two options is just remove it or update it. You can't view the contents of your secrets. So I think it's a good practice or good thing that you can't do that, right? So this is the place from where action's gonna pick up your credentials or secrets. Okay, let's see. Okay, my merge is done. Fantastic. Looks like the code is done. I'll again go back to the PR and see. Yes, I should have now have two comments. Okay, this was the first one. This was second one. I think it's the same code base, so there's no fancy thing here. Okay, good. Now, what should we do as a software developer? We need to create a new release, right? So create a new tag first. So let's go to tags and okay, let me do it from CLI. That's easier, right? Tag. Okay, I want to tag it to version 0.4, and the tag is 0.4. I'll do a tag. Oh, come on. My ZSH is not behaving correctly today. Come on, ZSH. Or maybe I'm using too many plugins. Okay, here we go. Come on. Git push origin v4. So I'm just pushing a tag, which I just created here. Okay, the tag is pushed now, version 4.0. Okay, let me refresh this. Okay, the new tag is here. Let's go to actions and see. Did it triggered? Yes, it triggered on version 4.0, a new deployment in our case. This is going on. And maybe what we can also do is, I've not tried it. Yes, let's do it in the live demo. What if I do if one deployment is going on? Let's create a new release. Okay, I want to release. Hold on, I want to create a new release. First one releases. Okay, I need to go to tags. Tags 4.0. Create a release. Release typo. Prod release. Okay, and publish release. Okay, congratulations. We just released our Hello World program for the world. And let's go to action and see what does. Okay, good. So the last one, I was slow enough. So the last one, so the tag, the deployment with the tag changes or the tag event got deployed. And now GitHub Actions is deploying my another deployment for my app. Imagine it's a production on the production cluster. Basically going to do everything for you, right? Exactly the same thing, because generally in a software development cycle, you want to create your dev, test, and prod environment as equal as you can, or as on the same level as you can. It's just that the number of nodes and the compute power varies, but the process should look like this. You should not be changing a lot of things while moving from dev to test to prod, in general. Okay, fantastic. So our code is deployed, and boom, again, I just have a single cluster right now, but you could deploy this onto as many clusters as you like to, and yes, my app is up and running on the OpenShift environment. And just to verify, I still have like 4 minutes to go. So yeah, so OC get deployment and pods. Okay. Okay, I can do only one. OC get deployment. OC is a kind of equivalent to kubectl. If I do kubectl, it will also work. Come on, it's taking time. Okay, good. So my GitHub Action Python app is up and running. It's going on, and OC get pods. Okay, good. So my pod is running, and it's been running since last 4 minutes, and so is my racing game pod. Okay, good. So this is how a typical workflow look like from using GitHub Action, and how you could use this tool in your development cycles and environment. And that's all I have for the demo for you guys today. I mean, I invite you, if you guys want to play around Kubernetes and OpenShift, you can grab your free cluster via just visiting to developer.com and just create a free account and launch a cluster, and that cluster would not go down.